Hello everyone, and welcome to this short introduction on basic relations between sets. In this session, we will explore how sets can be compared using the ideas of inclusion, identity, and something called if and only if. Let's get started. First, let's discuss the idea of a subset and a superset. When you see the symbol that resembles an underlined C and is spoken as is a subset of, it means that every element in the first set is also an element of the second set. For example, if one set contains the element 1 and 2, and another set contains the elements 1, 2, and 3, we say that the smaller set is a subset of the larger set. Formally, if we label the smaller set A and the larger set B, we can write A is a subset of B. The reverse ID is a superset, denoted by the symbol that looks like a mirrored version of the symbol for is a subset of. This symbol is spoken as is a superset of. Continuing our example, since B contains all the elements of A and possibly more, we say that B is a superset of A. Next, let's look at what it means for two sets to be identical. Two sets are considered the same or equal if they contain exactly the same elements. Mathematicians refer to this principle as the axiom of extensionality, which simply states that if two sets have the same members, they are the same set. When we want to emphasize that two statements must be true at the same time, we use the phrase if and only if. This is often shortened to IFF. So we might say two sets are identical if and only if they share precisely the same elements. In everyday language, you can think of if and only if as meaning in both directions. Each set has everything the other one has and vice versa. Now let's introduce the notion of a proper subset, signified by the symbol C, spoken as is a proper subset of. A set A is a proper subset of a set B if A is a subset of B and A is not equal to B, meaning A does not contain every element of B. This makes sense intuitively. If A lacks at least one element that appears in B, then A is truly contained within B. For example, if A is the set containing 1 and 2, and B is the set containing 1, 2, and 3, then A is a proper subset of B because A is missing 3, which B has. You've just taken a quick tour through the most common ways to compare sets: subset, superset, and proper subset. Being comfortable with these concepts opens the door to deeper set theory and mathematical reasoning. Thank you for joining me, and see you next time.